Okay, ladies and gentlemen, to continue with our notes at a 9.2, we just finished 2's graph up. Let's jump into 3. Let's start with our horizontal asymptote, just like we have over here in our mock problem. Remember, it is A over C plus E. Now, E in this case is 0, if you remember from your chart on the last page. This would be 1 over 3 plus 0. So our horizontal asymptote in this case is 1/3. So what that means basically is when I come down here for y equals 1/3, I have a horizontal line at 1/3 through my graph. So we will not cross this. This is y equals 1/3. That's my horizontal asymptote. Let's go with our vertical asymptote. So this is where we'll get 0 in the denominator in this case. So 3x plus 3 equals 0. We saw that for x. Okay, this would be -3 divided by 3, which is -1. So we'll have a vertical asymptote at -1. So that would be here. So we draw a vertical line where x is equal to -1. We will not cross that line. Okay? As far as going to graph this now, actually I have to solve for some points here. So what I'm going to do is I'm going to test points from 0 and up. So my T chart going to the right, I'm going to go 0 first. If I put 0 in here, I get -2 on top over 0 plus 3, so that's 3. So -2/3 will be your point at 0. So 0 down 2/3. We're going to be here. I'm going to test 1 now. So this is going to be -1 over 6. So -1/6. That's barely below the x-axis. And I'm going to go 2. So that would be 0 over 9, which is 0. Okay, and I can kind of see what's happening here. It's probably going to be a real steep line as I approach this and then really level out quick. So there is my graph to the right of my vertical asymptote. I'm going to go to the left now. I'm going to do this in red. So I'm going to start with, let's go -2, looks like my first real significant point. So I have -4 over -6 plus 3 is -3. So it looks like 1 1/3. So I'm going to go -2 up 1 1/3. Okay? And I'm going to do -3. -3 in that, make -5. -3 times 3 is -9. -9 plus 3 is -6. So we're looking at 5, 6. Just barely smaller than 1, basically. Okay? And you can see here this is getting really close to get-go. So I'm going to be really close, and then I'm going to jet up here. Okay? And there will be my graph for number 3. Take some time getting used to it, okay, but you want to work through these slowly and systematically. You can use your T-table on your graphing calculator for this. That's not a problem. I'm doing it by hand. I'm going to walk you through 4 and 5, okay, and then we're going to jump off the graph, so I'll let you continue there yourself. So let's keep moving here. Clear this off. I'm going to jump down to 4, okay. So here we go with 4. Let's start with your horizontal asymptote again. So this is going to be A over C plus E. So my horizontal asymptote will be y equals 0 over 1 plus 3, better known as 3. So at 3, I'm going to make a horizontal asymptote. There is y equals 3. So we will not cross that horizontal asymptote. All right, let's go vertical asymptote. This is where your domain won't work. So x in this case would be +4. At 4, I'll get 0 at the bottom. That will not be able to be done. So I'll get 0 on the bottom. That's on the bottom. So at x equals 4, I'm going to have a vertical line here. Okay? And moving right along, we're at my point now where I can do my T chart. This is x equals 4. So I'm going to go to the right of that vertical asymptote. So my first value after 4 is 5. If I put 5 in here, I'm going to have 5 minus 4, which is 1. So that's negative 1 plus 3. It's 2. So at 5, I'm up 2. All right, so let's test 6. 6 minus that is negative 1 over 2. So we're looking at negative, or 2.5, basically. So 6, 2.5. I can see I'm getting closer and closer here. So I'm going to be really close to my asymptote, and then level off. Okay? Okay, so we go to the left now of my vertical asymptote. Again, I'll do this in red. So the first number to the left would be 3. So 3 minus 4 is negative 1. Negative 1 over negative 1 is 1. 1 plus 3 is 4. So 3, 4 is our first significant point. Kind of can see what's going to happen here. If I put 4 in, 4 minus 4 is, yeah, I went the wrong way. Let's go 2. Okay, so negative 1 over negative 2 plus 3. So that's 3.5. So I'm at 2, 3.5, and I can see I'm going to be really close here and gradually take off as I approach x. Okay, so there's my graph for 4. I'm going to take you through 5 yet, and then I'm going to make a jump. Okay, so let's start with 5. Same thing as normal. Let's talk about this horizontal asymptote. Again, remember this is A over C plus E. So in this case, it's going to be 0 over 1 plus 0. So this one's y equals 0. So that's nice. That's basically your x-axis. There's your horizontal asymptote. Right? Vertically, what we're looking at is x plus 3 is equal to 0, so this one's going to be x equals negative 3. So, negative 3, we're going to need a vertical line. Okay. Let's start to the right again. So the first number larger than negative 3 is negative 2. So when I put negative 2 in here, I'm going to get 6 divided by 1. So at negative 2, I'm down 6. 1, 2, 3, 4, 5, 6. Let's try negative 1. If I put negative 1 in here, it's 6 over 2. That's 3. So negative 1 down 3. Check that. I'm doing these all upside down. Negative 2 up 6. 1, 2, 3, 4, 5, 6. And negative 1 up 3. Yeah, sorry about that. Small mishap. Alright, so let's go ahead and do 0. If I put 0 in, I get 2. 0, 2 is here. I'm going to plug 2 in. Alright. So if I put 2 in, I get 6/5. And now we're starting to make some headway. So that's 1 1/5 here. I'm going to go 6 now. So that would be 2/3 because 6/9. So 2, 4, 6. And we'll be out here. So that gives me a pretty good representation of my graph. Okay, so there's the right side. Left side. First number after negative 3 is negative 4. So if I put negative 4 in here, I get negative 6. So negative 4, 1, 2, 3, 4, 5, 6. Now I'm actually down here. Negative 5 will give me 6 over negative 2. This is negative 3. Okay. Negative 6 will give me 6 divided by negative 3. This is negative 2. And I'm going to do this point or this point. Actually, I'll do this one here. So this is 6, 7, 8, 9. So at negative 9, I'm going to get negative 1. So here's my graph for number 5. Okay? So hopefully you're seeing the pattern here. Again, your T-charts, you can just use your graphic calculator. Match your points up. Make sure you're labeling those vertical asymptotes and horizontal asymptotes. Okay? Okay, ladies and gentlemen, here we go. We're going to write an equation that represents the average cost per person. Now, each person costs $9.95. Taxes, how many people are coming, plus $18, regardless of how many people are coming. This is going to be divided by how many people are coming. This is going to be your average cost. Okay, so there's your equation. We're going to estimate the number of people needed to lower the cost to $11. So, you want to know when this value is going to be less than $11. So this is what I have to end up doing. Multiply x out of the denominator. Okay, so we have basically 11x is greater than 995 times x plus 18. I'm going to now subtract 995 from both sides. So the difference between $11 and $9.95 is $1.05. It's greater than 18. So I need to know what 18 divided by 1.05 is. So if I type that in my calculator, I'm getting 17.14285. Obviously, we can't have 0.14 per person come. So estimate the number of people needed to be lower than 11. We would need, and it has to be 18 or more people. Okay, so that's kind of what we're looking at. N is 18 or more people to get that cost in row 11. Describe what happens to the average cost per person as the number of people increases. Okay. The price per person will approach our horizontal asymptote, which in this case is $9. Our average cost per person will approach $9.95. Okay, as you go to infinity, as this goes to infinity. So the cost per person would be about $9.95 a person. Okay, so that's what's going to happen as you keep increasing. Okay, here we go with number 2. Speed of sound is modeled up here. Notice this is speed per second, temperature in degrees F. So we're going to write an equation that represents the time it takes to hear. Okay, so to take a look at this problem, remember distance equals rate times time. Right? In this case, we're solving for time, so time would be equal to your distance divided by your rate. Now, if you're 1 mile away, that's equal to 5,280 feet. So what we're looking at is time will equal our distance, which is 5,280 feet, divided by 1.09 f plus 1,087.8 feet per second. This will cancel out feet when it's all said and done, leaving you with seconds once you know what f is. So we're going to graph the equation using our calculator. So what I'm going to do is I'm going to bring up the calculator here. Okay, so I brought up my calculator. This is what I'm plugging in here. 5,280 divided by 1.09x. X is degrees. And 1,087.8. Now before I hit graph, I know I'm going to have to make my window a little bit larger. Okay, T is your temp, or I should say F is your temp, so X is my temp. Obviously I want to go up to like 110 degrees here. I'll leave -10 there, scale of 10. My Y min, I can leave it -10. This is going to be over, I don't know, time-wise, seconds. I'm going to probably keep the Y max as 20. Okay, I don't think it's going to take more than 20 seconds. In fact, I'm pretty sure. So there's our graph. Okay, so we graph it on our calculator. Estimate how long it takes to hear the thunder if it's 75 degrees out. So what we're going to do is hit second trace, type in value of 75, because remember, X is our temperature. So it's going to take about 4.514559 seconds to get to you. Okay? Describe what happens to the length of time it takes for thunder to reach your ears as the temperature decreases. So as the temperature decreases, let's see what happens here as I trace this. So if I'm going back, the temperature is decreasing. It's taking longer to get to you. So the lower the temperature,